First of all, we will see the spectrum spread of a local broadcast station. You can see that it is very wide, maybe spreading about 10 kilohertz on either side occasionally, but most of the time it is not that much. You can see that on either side you can see the side bands, and in the center you can see the carrier. And when the modulation is not there, you are seeing the carrier alone. Now what you are seeing is only the carrier. That is a pause between the announcements. And now again you can see modulation. Both side bands, upper and lower side bands, are clearly illustrated in this recording. I used centering of the frequency, and then on either side the spread also has been expanded. Now we can see the spread of the SSB signal. This is a lower side band, so the signals are below 7150, which is the net frequency, AirNet India frequency. You can see it is going beyond the minus 2K mark. You can see that it is going beyond the minus 2K mark. Earlier, when I kept it at 5 kilohertz width, it was not covering the whole. I'll see once again. See, it is covering beyond that. That means the spectrum is more than 2.5 kilohertz. 5 kilohertz centered means one side it will be 2.5, another side upper side it will be 2.5. So I am increasing the span back to 10 kilohertz. Now the full spectrum can be seen here. This is the spectrum of a lower sideband signal on 7.15 megahertz. That's the AirNet India going on there. Spectrum of an SSB signal. I have centered it, and the span is 10 kilohertz. Now I am looking at the spectrum of CW signals. You can see that each signal is quite narrow, and multiple signals seen are from different stations trying to work a de-expedition. Sagar Island de-expedition Alpha uniform to Sierra is around, and everyone is trying to catch that station. I didn't try because most of them are very fast, and I couldn't hear the de-expedition. Mostly I am hearing the stations trying to contact Alpha uniform to Sierra. I am changing it to 5 kilohertz so that you can see the spectrum well. Now you can see the spectrum over there, and I can fix it to the center also. Now the signal will be in the center. And once again I'll change the span. Now you can see the span of the signal. It is about 2 kilohertz or more. There's another thinner signal coming here that is different. I'm just checking the span of the signals just for curiosity. Here is another digital signal on 10 meter or 28 megahertz band. That also has a spectrum width of almost 2 kilohertz.